And g'day there to everybody in Tarlee. It's Graham Anderson here with a quick climate update for autumn 2016. Okay, well, I speak to a lot of farmers around the place, and they all say, listen, one thing we want is better forecasts. And believe it or not, forecasts are getting better. Bigger computers, lots more data points, a lot of better understanding of what drives our seasons. So that's all good. But there's also important, it's about improving our climate literacy so we understand forecasts. And that's sort of part of what today's talk's a little bit about. And also, I guess, no matter what the weather throws at us, there's a big thing that's under the control of farmers, which is really the seasonal risk tools, tactics, decisions that just deal with whatever the weather throws at us. So that's what you guys are really good at. And I guess really today is just a bit of a quick update, and it's brought to you, I guess, by a new project which is around just improving how we get good climate variability information out in the hands of farmers. So just a quick review, March rainfall in South Australia. So we can see here anything over the yellow is more than 25 mil. So you can see a bit of a zone here of 25 mil and less, but also some areas which got over 50 mil during March. So some places off to a good start already. Now here we've got summer rainfall, December, January, February for South Australia. I'll just explain deciles. Decile 1 is where the rainfall for summer was the equivalent of the driest 10% of summers, and decile 10 is where it's rained somewhere and it's the equivalent of the wettest 10% of summers, which is some parts up here. But largely you can see a lot of average, and a few places got a bit wetter, and a few places just sitting on decile 2, 3. Just looking at the last 12 months, so 2015, we can see there's a bit of a mixed bag around the place. Down further south, a lot of decile 1, which is driest 10% of years, and you can see you didn't have to travel too far to your north, and you had places which were actually up to decile 8, 9 or 10. So very event driven last year, and some areas getting dry, but some areas having some good rainfall. If we look at the last 2 years, so that's 2014 and 15, we can sort of see again that similar pattern, dry area. Some areas here in Western Victoria, Southern South Australia, lowest 2-year period of rain on record. But again, you don't have to travel too far north where it's been largely average. So we'll talk a little bit about what's behind that. We all remember 2010-11, that was the wettest 2-year period in Australia's history, and it wasn't just wet in your part of the world, it was wet all the way up to Northern Australia. So one of the big things we'll talk about is where did all that moisture come from, and what's the difference between these really wet years and dry years. So we'll talk about where all that moisture came from. And there's a longer term story too, especially for parts of southern Australia. This is just referring to that sort of growing season rainfall, April to October. But since 97, compared to longer term records, parts of southern Australia has had a fairly dry and lowest sort of growing season on record. So we're in a bit of a period where that's happening a bit more often. Also, you don't have to go too far north where that's been more like the long term average. So we'll just talk about what the climate scientists think's going on there. Now here we've got a nice long-term rainfall record for Tarlee, and it goes all the way back to 1882. You can see back here at 1882 all the way through to 2015. And what this is an anomaly graph which has got the long-term average based on 470 millimeters right through the middle there, and you can just see years where it's wetter, perhaps up to 700 mils in those really wet years, through to years where it doesn't even crack 300 mils. So a lot of variability in the system there, but when you look at that long-term record, well, it just looks to be variable from one year to the next. And when I look at that last 20 years, I see a lot of rainfall records for places, but gee, I think you've been batting a bit better than the average for a lot of places in southeast Australia. So that's pretty good there. You got a pretty good mix there of wetter years and dry years. Now what we've got here, just looking at that same record, but looking at summer rainfall for since 1882 for Tarlee, and you can see there lots of variability there. A run of perhaps drier summers there through 70s and 80s, but some pretty wet dominated there. A couple of really wet summers there, but so that's probably been useful in the last couple of years. autumn rainfall record, when we look at that long-term autumn rainfall record, 109 millimetres is the average. Probably we see here there's quite a few places in South Australia where autumns haven't been as good, perhaps since the 80s. But probably, if you look at the last 10 years, that's a run there of autumns where, again, been batting pretty well. So I think a lot of farmers in different parts would probably swap with you there. So that's good to see. And winter rainfall for Tarlee, so 167 millimetres is that long-term average. Again, plenty of variability, and really no noticeable sort of trend there in that recent history. And spring, so spring's quite variable, 128 millimetres, all important. I guess again, what makes a difference from a really wet spring to a drier one? I guess you've had last year was pretty close to average, probably just had that quick finish like everyone else, and then there's a run of springs there which are a bit drier than average, but a lot of variability. And what we'll talk about is is there anything that can give us a heads up as to whether we're likely to have a spring that's down here into the less than 50 mil versus those springs where there's over 150, and we'll try and make some sense of those key. Now here's the 4 big drivers of our wetter or dry years. You can see here weather events circulating around southern Australia, the southern annular mode, lots of cold fronts there, and they're really important triggers for rainfall. But one of the things that's typical of wetter years is we get a much better flow of moisture out of these really warm oceans. We've got El Nino southern oscillation. Some years it sends us a lot more moisture, and they're La Nina years, and other years, the El Nino years, the moisture flow is broken down or it heads the other way. So that moisture is a really key part, that it not only is it the weather events we get, but also is there a good feed of moisture coming in for winter and spring rainfall. And the same with the Indian Ocean dipole. It can be really helpful some years for moisture flow, or other years it doesn't play ball. In drought like 2006, we had an El Nino in the Pacific, less moisture from here. The IOD was also in its dry phase, so there's just less moisture to make rain in those sort of winter-spring periods. In spring 2010, La Nina in the Pacific, plenty of moisture barreling in, and the IOD was also in its wetter phase. It had plenty of moisture as well, so in those years they're really wetter. So I guess part of seasonal forecasting is around understanding the preconditions for how these oceans are setting themselves. Now, just to show the effect of some of these oceans on moisture flow, we're just looking at a dry pattern here from September 2006. Now, what we're looking at is a sea surface temperature anomaly map. Now, these oceans along the equator are always a lot warmer than swimming down the south here, but this is an anomaly map. So it's just showing areas of ocean that are warmer or cooler than long-term record back at September 2006. And you can see here these sort of warmer colours, that's where an area of ocean might be 2 degrees warmer than its long-term average, and this blue colour is where an ocean's cooler than average. Now, here we've got back in spring 2006, dry year, we had the El Nino there in the Pacific. You see all the warmer water over there, but notice around northern Australia we've got a lot of cooler than long-term average water there, and in those years basically more of the moisture is happening where the warmest of those oceans are at the equator, so where the warmest water pops up. And so in those particular years there's just a bit less moisture that's feeding into our rainfall patterns down in southern Australia. Now what I want you to do is just have a quick look at this area to the north of Australia and watch as we look at say the wetter spring of 2010. See if you notice any difference. Well, there you go. That's you can just see the difference. Big La Nina there in October 2010. Cooler water over here, but really warm oceans over this side, which means plenty of moisture being generated by the warmer ocean feeding into our weather patterns. So that's just one of the things that's behind these, I guess, seasonal forecasts, and it's particularly important for our part of the world in that sort of late winter and into spring about how much moisture those oceans are sending our way. Now what we'll just look at is we'll look at see what's happened in your district in those previous El Nino and La Nina or Indian Ocean dipole events. And one thing to remember is that in normal long term, a third of the years are deciles 1 to 3 and the dry deciles. A third of the years are wetter in decile 8 to 10 or a third average. So we'll just look and see if there was any difference in these El Nino or IOD years. So looking here, you can see in El Nino years there for the winter and spring, the areas that's usually drier, decile 3 or 2, less moisture coming in from the Pacific, so this is where in Australia is drier. And when we look at Tarlee's August to October rainfall in the previous El Nino events, rather than just a third of those years being decile 1 to 3, you can see that almost 2 out of 3 were decile 1 to 3, so quite a signature there. of El Nino years. But you can also see that there's still the occasional El Nino that's wet. 1 in 4 is wet. Or average. So it changes the odds, doesn't guarantee. It just means that in some of those other years there's a source of moisture coming from somewhere else, likely to be the Indian Ocean or something. In La Nina years, when there's plenty of extra moisture flowing around in Eastern Australia, when we look at the fingerprints on that August-October, it's not as strong for Tarlee. We can sort of see that it's largely about the same chance, perhaps a bit more chance of average, slightly reduced chance of drier spring, but not as strong as the El Nino signal. And when we look at the Indian Ocean dipole, you can sort of see when it's IOD positive, which means actually it's sending us less moisture. It's less helpful mood for winter and spring rainfall. This part of southern Australia tends to be affected, and when we look at that there for Tarlee in those IOD positive years, increased chance of drier, but again not perhaps as strong as the El Nino there. When the Indian Ocean dipole is in a good mood and sending extra moisture and being more helpful for this part of the world, it's really interesting, quite a strong signal there for Tarlee when we ever look at that in those previous 20 events, August to October rainfall, rather than a third chance of being decile 8, 9, 10, it doubles that chance. Still the occasional dry one, but quite a strong driver. So I guess it's worth keeping an eye on these oceans to our north and taking on some of those signals to see what sort of mood they're in as we approach. Now, seasonal forecasts, I had a farmer just say that really it's a bit like getting the minutes of the latest Reserve Bank board meeting, and I think that's a really good way to put it, that there's never any guarantee what actually happens, but if there's some background information or commentary on what those oceans to our north are up to, and whether they're in a more helpful mood for winter spring rainfall or a less helpful mood, it's probably just worth knowing about it so you can feed into your planning for the different spring finishes you might be getting in your part of the world. And one of the things too about seasonal forecast, autumn usually is a less predictable time of the year than it is in the winter and spring. These oceans are still setting themselves up at the minute, but once we get to sort of winter, we've got a better idea about whether the Pacific Ocean's going to zig towards wetter or drier phase, and the same for the Indian Ocean. And I'll make the analogy, it's a bit like AFL footy season. I've got friends who are very keen Richmond supporters, and in February, March, they're always very excited about where they're going to be at the end of the year, but there's nothing like just seeing how your team's form is travelling. Once you get to June, July, you've got an idea of whether your team's going to be top 4 or bottom 4. So it's a bit the same with the oceans, and that's why it's good to read that commentary as you go through the season. And we provide a bit of that commentary too. The break and the fast break newsletter, Dale Gray, our seasonal risk agronomist, does a great job of those, and I'll show you where you can keep track of some of that in terms of how these larger climate drivers are shaping up from one year to the next. And one of the things that are in the fast break, we've got a table here, and I'll just explain what this is. This has just been done for South Australia, and basically here along the top we've got a number of the different global seasonal forecast models. So we've got the European seasonal forecast model, the Bureau of Meteorology Australian model, the Japanese, a couple of USA ones, NASA, Japanese. All of those are a different outlook on seasonal forecast. Now these will run in March or May. This is actually the forecast month, so April, May, June, April, May, June, March, April, May, and this is where they're saying, well, what's happening out in the Pacific Ocean? So there's a number of oceans they're thinking for the next few months it's still a bit of an El Nino that's starting to cool off. The eastern part of the Indian Ocean, most of the models they're saying, well, that area of ocean up to the northwest of Australia being warmer, and their predictions for autumn rainfall for South Australia, well, you can see there's a number of them through there that have got a hint of slightly wetter in your part of the world. So fingers crossed that comes through. So it means there's a few things that are in our favour, a bit better than this time last year. Still no guarantee when the autumn break actually happens, but at least it's just saying some of the background conditions there are going to be helpful. Now this is just looking at that same table, but it's for the 3 to 6 months out, and that's these are those same models, but Dale's just crunched these looking at July, August, September, and what they're thinking. So it's good to keep track of these from one month to the next. Basically, though, as the season gets on, there's a couple more models they're thinking that El Nino will cool down, and they're just sort of a bit of debate of whether it might be a La Nina or not. So we'll have to stay tuned with that one. In the Indian Ocean, there's again that water still remaining warm, which is sort of potentially useful for us. So that'll be something to watch this year. And again, there's still a couple of models there that are hopeful that there'll be a bit of better moisture flow later on the year. So stay tuned with those forecasts as they get updated each month. Now, any curveballs, what I've been talking about is largely just good old-fashioned variability. I guess one of the things that's a little bit different at the moment, that which is around this longer-term temperature record. You can see back to 1910 up to last year, and see temperature does vary up and down, and even El Ninos and La Ninas tend to vary, where La Ninas are cooler and El Ninos are a bit warmer. But each decade, basically since the 50s, has been a little bit warmer. And the main thing that's, I guess, a bit of a challenge for us is really around spring temperatures. When we're looking at spring maximum temperatures for South Australia, and you go back through the last 100 years, certainly in those, you look at the last 4 springs, we've had a number of them between 2 and 3 degrees warmer than that long-term average. So that basically is just summer arriving a bit earlier. And if we've got plenty of moisture, that's perhaps not so bad. But if it's years where things are a bit dry, it just brings a finish to the spring a bit quicker. So that's one thing that's probably a little bit different to just long-term variability. Also, with that, while we've got warmer days, the issue of frosts and late frosts is still a bigger risk as ever, and I guess that's one of the things that we're dealing with too about. And it's usually comes with that sort of, when we get that settled, where the high pressure pattern, not only is it dry and warmer during the day, but we got a chance of picking up spring frosts. So that's something we're dealing with at the minute. And that's, I guess, that trend in the pressure pattern since the 50s. The Bureau sort of doing a lot of measurement and picking up that there's the increase in pressure pattern over southern Australia, and that's sort of part of what's probably giving us a few more bumpy springs, and also with that frost issue. And here's that basically that pressure, southern Australian pressure. You can see it's quite variable from 1950 through to 2015, and you can sort of see the big El Ninos. There's a higher pressure over southern Australia. We've got the 97, 98 and the 06 El Nino, and but last year. So one of the things, though, that while there's variability there's just every sort of 20 years or so, it just nudges up in terms of a higher pressure over this southern part of Australia. And I guess you might have seen this. This is just some recent sort of work on looking at rainfall zones and summer dominant rainfall versus uniform and winter dominant rainfall. So that's not a bad little paper there, just talking about how since 2000 basically some of our rainfall zones have shifted south compared to long-term average. Now, farmers are used to variable seasons, and they've had a lot thrown at them in the last decade, and whatever we get thrown at next, it's good to look at all the things that are under our control. And really, farmers have done a great job at managing that variability, and these are the sort of things that we'll need to keep on doing to manage whatever the weather throws at us. And we've got modern technologies, equipment, genetics, all those sort of things are improving, helping us deal with variable seasons. Improved sort of farm infrastructure and regional infrastructure, on-farm storage, they're all things which help us. Business management for variable years and incomes has been a really key bit to how some farmers are really managing this variability of weather. And also just things like conservation tillage, better soil health, they've been really important in terms of how we store moisture and keep it there for our crops to use. And things, soil probes, and how we manage seasonal risk by doing all of that. Weed control over summer, storing that moisture. It's really a credit to farmers and how well they're managing variability in this day and age. So we'll need to keep doing all of that, and good luck with the year ahead. And if you're interested in getting those sort of monthly updates, just drop an email to thebrake@ecodev.vic.gov.au. It's free, and you can give a bit of a trial and see if the commentary is any use for you this year. Good luck.